Hello colleagues, let's discuss today a very typical case when customer received equipment, tried to deploy it in the lab and failed. So what are the mistakes done? Number 0, we don't know whether this mistake was done or not, but remember, when you get their equipment, update the software. Update the software on each and every beacon, the modem and the dashboard. That's the starting point. All the software must come from the same software pack. Download the latest software pack and update the software always. So this is point 0, ground 0. Then let's move forward, because of course the customer sent us along a mail, we replied, and I thought that it would be a great idea based on this example to explain other people what should be avoided and how things should be done properly. Now, first of all, line of sight. We do have plenty of materials about line of sight. Nevertheless, this is the most misunderstood notion. What is line of sight? Since our system is based on ultrasound plus radio, correctly to say line of hearing. But then the question is line of hearing between what and what? So this is industrial super beacon. So this is metal transducer, and next to the metal transducer there is a microphone. So line of sight must be between their transmitting transducer and receiving microphone, between their transmitting transducer and receiving microphone, and in opposite direction, transmitting transducer and receiving a microphone. Because this case stopped even before tracking of the mobile beacon, because even their table of distances was not built properly. And it's pretty obvious why it's not. Now let's look at this. For example, line of sight from this transmitting beacon, stationary beacon, stationary beacon, stationary beacon, stationary beacon, mobile beacon. So line of sight from this transmitting beacon to this receiving microphone obviously was non-line of sight, because the microphone is facing up. Microphone simply cannot see the beacon placed here. The same here, the same here. So it means that when the table of distances is being built, the system is trying to measure the distance from this point to this point and from this point to this point. When this is transmitting ultrasound, this beacon can hear. But when this beacon is transmitting, this beacon cannot hear, because the microphone simply cannot, look below horizon. And horizon for this beacon is this. So this is below horizon. Okay, this one is already enough for the system not functioning at all. So again, remember, line of sight. Then again, I'm jumping a bit, but for example, this beacon maybe could, but most likely couldn't see this beacon, because this part would be non-line of sight for this beacon. Of course, the system is trying to get some information, but in this case, the system will be able to get information of reflection, etc. So this is the problem. As soon as you provide line of sight, there is no problem about reflection. There is no problem whether it's metal around or wood around or plastic or glass. It doesn't matter. But line of sight is a must. If line of sight is not provided, then all kind of reflections or phantoms or jumps or whatever is coming, only because line of sight is not provided. Line of sight between their transmitting transducer and receiving microphone. Okay, so that was the capital error in this. It must be avoided. Then no height. It's a less major error, but nevertheless. But it became a more problem because a more complex map, 3D map with several heights were provided. So if you do not provide the height for the station beacon, then the system even theoretically cannot build the system and cannot measure the position, because it can measure the position of the mobile beacon against the stationary beacons, but then the stationary beacons must be against something. What is this something? This something is typically a floor, as we call it. So for this beacon it must be 0, for this must be some height set, some. Okay, so each stationary beacon must have the height set. If it's not, then the height is 0. And of course height is not 0 for this particular configuration, because this is on whatever 1.2 meters, 1.2 meters, 0, 1.2 meters. So the geometry couldn't even theoretically build because the heights were different. But the system assumed that the height is the same. So major error. But line of sight is even more. Always set the heights for the station beacons. Then, even though the table of distances was red, and the system was trying to report, hello, I have a problem, I cannot build the map of beacons properly. I cannot build the map of stationary beacons distances properly. Nevertheless, there was an attempt to track the mobile beacon. Now, at this point of time, clearly stop, don't. Of course, they wouldn't be able to track properly, and that would be just losing time, because again, we always recommend do step by step, small steps. If the table of distances is obviously red, the map of beacons is obviously incorrect. Of course, you cannot track the position of the mobile beacon properly. It would be something. So do not go further until every previous step is correct and satisfactory and tracking is perfect. You can extend it further, for example, and we have also articles about this, when you try to integrate, when you try to build complex maps consisting of multiple submaps, or you want to do a paired beacons configurations. Go there only when the previous steps are correct and everything is perfect, green, white, and perfect. Many things could have been avoided if instead of complex 3D, basic 2D would be built. For example, what is basic 2D? Our recommendation is very simple. Put the station beacons on the wall, high on the wall. Why? In this case, it's more difficult to make a mistake with a non-line of sight. So this beacon and this beacon, for example, could be put on some wall, and then okay, fine. Then line of sight is almost automatically provided because it's difficult to make a mistake, and there wouldn't be a mistake with height, because even if you didn't set the height, okay, there will be shift, but they will be still tracking. So there will be shift in XY because you didn't provide Z, but you would be still having normal tracking and very good tracking. So it means that by properly following our recommendations, many mistakes could be even avoided right from the beginning. I will not go further and deeper because this covers like, I don't know, 70–80% of the mistakes, and with line of sight is the most important. And remember, line of sight between their transmitting element and receiving element. In terms of super beacons, transmitting elements are transducers and the receiving element is the microphone. So the microphone must see this, not mechanical body or chassis or something. The microphone must see it, and the microphone cannot see below the horizon. We do have a video explaining the same in deeper details. It's called Avoid Typical Mistakes video, so this is the link. Please watch this video as well. Avoid those mistakes and save a lot of time for you. Thank you very much.